All right, here we are in Chapter 1, Section 1 of Calc 1. And what we're going to see a lot of in this section is going to look like review. So I'm going to move through it pretty quickly. And this is actually the entirety of a homework assignment that I'm going to be assigning to my students. And I phrase it that way because in case somebody else is watching this who's not one of my students, that's why it is that I'm going through this at the rate of speed that I am. We're at the beginning of a semester, we're getting warmed up, and so let's just refamiliarize ourselves with some of the fundamentals. So again, just to get you started on these homework problems, I'm not going to work through all of these. This first problem, we're looking at a graph. Question says state the value of f of 1. This number 1 that's in here is an x coordinate. You're being asked for the y coordinate that has a corresponding x value of 1. So you're starting at 0, 0. You're coming over to an x value of 1, and you're going up to that point, and you have to input the y coordinate. This is also another x coordinate. You're being asked for the y value. Here we're being told that f of x, which is synonymous with y, f of x or y is, equal sign means is 1. And they're saying, what's the x coordinate, or what are the x coordinates, plural, when y is equal to 1? Go back to the graph and find points on the graph that have y values or y coordinates of 1. Estimate the value of x such that f of x equals 0. So again, we have another y value that we're being given to us. Here the y value is equal to is equal to 0. We want to know what is the corresponding x value. Part E says state the domain and range of f using interval notation. So we're assuming that the function stops right here and to the right stops right there. The domain is a list of x values represented by this graph. Our x values go on the graph from here all the way over to here. So what x values are those? And I would assume that we're including the endpoints because there are no open circles at the endpoints. I've drawn in some solid dots there. So let's assume that it's going to be a closed interval, which means you'll be using square brackets. And the range, of course, is the y values represented. So how low, if my pen will work, on the graph up there, how low does the function go up to how high does the function go? From lowest to highest. Always, when using interval notation, we're going from lowest to highest. When we're including values, we use square brackets. When we're excluding values, we use parentheses or open brackets. On what interval is the function increasing? I look at the graph and I always imagine a person, walking on the graph, moving from left to right. And if our person is starting out here, and the question is, where is our function increasing? That means when on my graph would I be walking uphill? And surely as I go from left to right, again, if my pen will respond, there we go. This is the portion of the graph where we're walking uphill. Now, the way that I learned this material, I'm being asked, on what interval is the function f increasing? We're being asked for x values here. So we need the x coordinate here at the bottom of the hill. We need the x coordinate at the top of the hill. So whatever that first x value is, whatever the second x value is. But because I don't really know what's happening at the bottom of that hill, because my graph kind of ends there underneath where my person is standing, I would tend to write that as an open interval on the left. And at the top of a hill, am I going uphill? Am I going downhill? I mean, if you imagine standing at the top of the hill, if I look to the left, it looks like it would be downhill from there. If I look to the right, it's downhill from there. I'm definitely coming at it I'm going uphill as I'm walking from left to right, but when you get to the top of a hill, are you still going uphill? I don't think so. That's where I'm going to sit down and take a break. So I would say that that's not increasing there anymore, and I would close the interval with a parenthesis. But be sensitive to the fact that different authors have different rationales and may be presenting this in a slightly different way. So don't hesitate to look at an example problem in the book, whether you're my student and we're all using the same book in my course, or if you're a student of someone else and using a different book by a different author. You could see open brackets, closed brackets, or perhaps open on the left end of this one and a square bracket on the right end. Problem number 2, this is a nice throwback. Consider the following graph. All right, and this thing goes flying off the graph there to the left and off to the right, so we assume that this thing goes forever left and forever right, and therefore forever up and down. Determine whether the curve is the graph of a function. If you went through the book that we're using and you watched some of the videos, read some of the text, you would be reminded of the definition of a function. Functions have to pass the vertical line test. This one definitely does not pass the vertical line test. If you look at the graph with me and you look at this point right here and this point right here and even this point up here, all of those points have the same x coordinate, and it's that repeated x value, the utilization of that x value, in this case -1, more than once, that tells us it's not a function. So we mark not a function, and if it's not a function, then we don't really need to answer either one of these. We can go DNE, does not exist. In question number 3, the graph shows power consumption, so we're turning this into a word problem now. And what is the power consumption at 3 a.m.? Your times are horizontal values. They're t values. You can see the t over there at the right-hand end of the graph. What was the power consumption at t equals 3 a.m.? So we're being given what we would normally think of as an x value, and over here you want to enter a y value. At 3 p.m., they're giving us another x value. You're going to enter a y value. When was the power consumption the lowest? Now, power consumption is on our vertical axis. And since it's on the vertical axis, those are y values. When was the power consumption the lowest? So you have to find the point on this sort of purple curve where you're at your lowest. And then you have to answer the question, when? In this case, when is literally a time, and when usually is asking for an x value. If you look again at the screen, the word what, as in part A, the word what is usually asking us for a y value. But in part B, when is looking for an x value, in this case a time when the graph is at its lowest point. Here, when the graph is at its highest point, we have another when being asked of us. Do these times seem reasonable? When you're in a word problem, it's always nice to ask yourself if your answers seem reasonable. It's a way to sort of help you check your answers and make sure that you're answering with an answer that's at least potentially correct, right? Something feasible would be nice. In question number 4, this is very much a straight algebra question. We're being given a function f of x, and then we're being asked to solve a bunch of these or evaluate a bunch of these expressions here, f of 2, f of -2, f of a, f of -a, and so on. How do I evaluate those? Do we remember how to do that? In this one that says f of 2, most of you are going to remember that you need to take this 2 and plug it in. The x value here is being replaced by the 2, so we're going to replace this x value with a 2 and this x value with a 2, so just plug it in. When you have to process an x value of -2, be careful, because the -2 gets plugged in here for x, and think of it as though you're plugging it in with parentheses wrapped around it. So that -2 has to be squared or multiplied by itself. Negative times negative makes a positive. Here again, be careful when that -2 goes in, you're now subtracting a negative. So you're going to have a double negative there, which will turn into a positive. So even though this is pretty fundamental, basic stuff for many of you, still exercise some caution. This is always strange when you see something like this, f of a. You are indeed just replacing the x's with a's. But then when you have to replace them with negative a's, again, like we did with the negative 2, use parentheses, think about double negatives, think about negative times negative, and answer accordingly. Combine like terms if necessary. You won't have to do that just yet. However, in the next problem, f of a plus 1, you are replacing your x values with a plus 1. And when you make that substitution, when you plug that in, a plus 1, put it in parentheses. Now this isn't the answer, even though I'm writing it in this space. But you've got a plus 1 squared minus a plus 1 plus 3. Notice that I put the a plus 1s in parentheses. When you take this a plus 1 and you square it, it's my pen, you'd think it's an Apple pen. I don't know, it's like a $110 digital pen, however much it was. I'd like it if it was a little more reliable. I don't know why it'll highlight text for me. Check this out. It was off screen. It'll highlight the part that's printed, but it doesn't want to just act like a marker, like an actual highlighter, and highlight the stuff that I wrote. So I'll just grab a different color here and circle it. When you square this, remember this is a plus 1 times a plus 1. And if you need to write that out, FOIL it, combine like terms, then make sure you do that. Once you FOIL and combine like terms, then you can multiply by 4, and you'll need to distribute that multiplication by 4, just like you're going to need to distribute this negative sign into these parentheses. Don't forget these basics. This is stuff that needs to be second nature by the time we get into the actual calculus of things. 2 times f of a means we need to take the entire original function and multiply it by 2. That involves distribution. Plugging in a 2a, plug in that 2a with parentheses wrapped around it if that's helpful to you. And it will be, because you're going to need to square that 2a. Here you're going to be squaring a square when you plug in the a squared. Here you're going to take the entire function, wrap it in parentheses, and multiply it by itself. That's going to be a trinomial times a trinomial. You're going to have to take the original expression and multiply it by itself. That's a superfoil. First term gets multiplied by all 3 terms. Then the second term gets multiplied by all 3 terms. And then the third term, the positive 3, is going to have to get distributed out and multiply all 3 terms. You're going to end up with 9 terms, and then you will have to combine like terms. Stay organized. Use lots of paper. Use a sharp pencil. And lastly, f of a plus h. You're plugging it in. You're foiling. You're combining like terms. You're distributing. You're combining like terms again. And then you're going to do something very similar to that in problem 5. Here is a function. You have to evaluate 3 things. You need f of 3 plus h, which is very similar to what you just did in the previous problem. So figure out what that equals. Go slowly. You're going to have to take 3 plus h and multiply it by itself. That's foiling and combining like terms. Then you're going to have to distribute a negative sign into all of those resulting terms. Then the 3 plus h is going to go in here. You'll have to distribute multiplication by that positive 3. And then lastly, this 2 is going to come into the picture, and that'll get combined into whatever you've got. And that's just f of 3 plus h. Then you have to subtract whatever f of 3 is. So figure out what that is separately. And then you've got this h down here in the denominator. So this is 3 problems in one, in a way. Once you've got f of 3 plus h, and this says minus the f of 3, you'll have to do some combining of like terms there, and then you're going to divide that expression by h. My hope is that in the numerator you have maybe no constant values. Maybe you'll get to cancel an h or reduce by h here, and reduce by h here. Don't forget, you have to do the distributive property of division. You have to divide both terms in the numerator by your denominator, which is simply an h there. This is pretty much the difference quotient. Oh, it even says it in the problem. It's the difference quotient. Evaluate the difference quotient for the given function. The lousy part here, previously I said it's basically the difference quotient because it just had an h in the denominator. Here, when I see this x minus 3, and I see this x and this 3, that's what really reminds me of difference quotient. But the previous problem, number 5, was. Number 6 is also difference quotient. Be careful with this one. This f of x is going to get replaced by not something so simple as a quadratic. It has to get replaced by a fraction. That stinks. Don't be intimidated. Even though you're in Calc 1, a lot of you still hate fractions. Don't sweat it. Just write it out, keep it organized, make it legible, take it one step at a time. Then figure out whatever f of 3 is. Plug it in, simplify, okay? Once you've done that, you're going to have a fraction, f of x, minus a number. You'll need to create a common denominator in order to do that subtraction. Whatever f of 3 is, 8 over 4, 2, okay? You're going to have to take the number 2 and turn it into something over x plus 1. And I'll give you a hint. You're going to have to take the number 2, or 2 over 1, and turn it into something over x plus 1. This denominator has to become an x plus 1. How are you going to make that happen? Well, whatever you do in order to make that happen, you're going to do it to the 2 also. And I would draw, there we go, I have to do that to the 2 also. Once you've done that, then you can actually do the subtraction in the numerator. Your denominator is going to have an x minus 3. My hope is that something magical happens and you're able to cancel out the x minus 3. I will leave it to you to figure that out. Number 7 says find the domain of the function. Remember, domain can be thought of as a list of x values that are a list of x coordinates being represented on a graph. Okay, earlier in this assignment, we talked about domain and we said how far to the left does the function or the graph go, how far to the right does it go, and there were points all in between there. So we said to use interval notation from lowest to highest. Here, we're going to be answering using interval notation again, but initially, a great way to look at this problem, and often to look at domain problems, is there maybe a really short list of x values that we're not allowed to use? Are there any problematic x values when we look at this function? There are. This function is a fraction. When do we run into problems with a fraction? We run into problems down here in the denominator. We don't want the denominator to equal 0, because if it does, you've got division by 0. We don't like that. We want x squared minus 36 to not equal 0. And we can solve this does not equal equation. This I don't want to call it an inequality, but I suppose it still is an inequality. If I add, my pen is just super malfunctioning, sorry. If we add 36 to both sides, and then we take the square root of both sides, I'm going to tell you that the square root of 36 is not just 6, but it's plus or minus 6. X cannot equal plus or minus 6. So on the number line, with negative 6 here and positive 6 here, it can be any of these x values. It can't be negative 6, could be anything between them, or anything greater than positive 6. I'm going to leave it to you to try to recall. If not, look it up. Do a little research and reminding yourself on interval notation, and figure out how to express this interval and there's a symbol that goes right here of some sort, and this interval, and this interval. All right, so it's going to be 3 intervals with 2 little conjunctions there, if you will. Find the domain of this function. Are there any restrictions in here? Is there any danger of division by 0? I don't see any fractions, so I don't think there's any danger of division by 0. Is there any danger of square rooting a negative number? Well, I don't see any square root symbols, so probably not. This expression is actually a second-degree polynomial. We have our variable t, and it's being raised to the first power, 4 times t to the 1, plus t to the 2. So our variable is being raised to exponents which are positive integers, t to the 1, t to the 2. That means that this thing is a polynomial. There's no division, there's no dividing by a variable, rather. There's no square rooting. So this one's a polynomial, and polynomials have domains with no restriction. So I will leave it to you to recall how to enter interval notation with no restrictions on it. All real numbers is another way to say that. And here is a request for us to sketch the graph of this equation. Is it going to be concave up or concave down? You actually want to be looking at the coefficient in front of the squared term in order to decide if it's concave up or down. And then, well, you've got 2 that are concave up and 2 that are concave down. Once you've decided whether it's concave up or down, then you need to choose between those 2 graphs. How am I supposed to do that? Well, I'm going to pick, this will actually work nicely. I'm going to pick the very first graph. Okay, I'm going to pick this one right here, and I'm going to try to determine, I think from looking at the equation that my graph is going to be concave up. I'm not going to say whether that's right or wrong, but I'm just going to assume that for the moment, and then I'm going to decide, well, is it that graph or is it this graph down here in the bottom right? And one way that I can determine that is by taking the x-coordinate of a point on the graph, like this point, 0, 0. I'm going to take the x value and plug it in. So plugging in an x value of 0, f of 0 equals 4 times 0 plus 0 squared equals 0 plus 0 equals 0. Okay, so that should be the corresponding y value. So 0, 0 should be a point on my graph. This point that I chose, it had an x value of 0. Does it also have a y value of 0? It sure does. So is that the correct graph? Well, unfortunately, I didn't choose a very good point, because 0, 0 is also on this graph, and 0, 0 is on this graph, 0, 0 is on this graph. So when you're choosing a point that's going to try to help you decide between maybe one of 2 graphs, either deciding between the concave up graphs or deciding between the concave down graphs, make sure that you choose a point that's unique to one of those graphs so that it'll actually help you tell the difference and hopefully make a correct selection. So pick a point with a unique x value, plug it in, and see if the corresponding y value gets generated. Alright, in number 9, we're finding the domain of this function. We're doing pretty good, 24 minutes in. Okay, and I think there are only 12 questions in this assignment, so almost there. Good quick review of some algebraic concepts. Here we want to find the domain again, and domain is going to be very important. Whether it's a Calc 1 class or like a business Calc, elementary Calc class, knowing the domain of your functions is extremely important. In word problems, surely you have to know whether you're working within certain time constraints or weight constraints or some sort of numerical quantity of items that are going into production or something. You have to be operating in the right realm. So domain is very important, even though this seems like kind of a nuisance going back that far, like we're going into an algebra class. So in a square root function, is there any danger? Definitely. We don't want to take the square root of a negative number. Am I allowed to take the square root of 0? Yes. What's the square root of 4? 2. Why? Because 2 times 2 is 4. What's the square root of 0? 0. Why? Because 0 times 0 is 0. All right, so 0 we can take the square root of. So I'm going to write it up like this. I'm going to note that x minus 13 needs to be greater than or equal to 0. The stuff, the expression underneath my square root symbol is called the, oh, I'm having a brain fart. I think it's the radicand, okay? And this little number up here, if there were a number, it's invisible, it's a 2 in this case because it's a square root or a second root, that number would be the index, okay? The radicand in this case needs to be greater than or equal to 0 because it's a square root function. We can solve this inequality by adding 13 to both sides, and we find that x needs to be greater than or equal to 13. You're supposed to be answering in interval notation, so I'll leave you to make that conversion. And also, do you remember what the basic square root function looks like? The square root of x? I'll remind you, it's in the first quadrant, and it's this kind of arc that goes out to one side. This is a function, the square root function. Is this graph a possible answer? No. Why not? It's not a function. This graph does not pass the vertical line test, so that one's out right away. If this is the graph of the basic parent function, square root of x, what impact does putting a minus 13, I'm pointing at it on my iPad like you can see where I'm pointing, what impact does a minus 13 after the x inside the function, inside the square root function, have on the graph? The answer is it has an opposite effect that you might think. It looks like it says negative 13 in there. It doesn't. It actually says minus positive 13. And the result is a horizontal shift. So we're going to move our original parent function that's arcing out into the first quadrant. We're going to slide it to the right 13 units. If the minus 13 had been on the outside of the function, if it had said the square root of x minus 13, and the minus 13 were happening on the outside of the function, that would have caused a vertical shift, and that shift would have been in the direction you would have guessed, in the negative or downward direction. So just a little bit of review about transformations of functions. And in that case, we got to talk a little bit about horizontal and vertical shifts. Find the domain of this function. Answer using interval notation. This is number 10. This is called a piecewise function. Piecewise function. And we do or perform this operation, x plus 2, if our x values are less than or equal to 2. For example, if I gave you an x value of 0, which is less than 2, or less than or equal to 2, you would take that x value of 0 and plug it into this x value, and then you would add 2 to it. If I give you an x value of 5, which is greater than 2, you'd plug the 5 into this expression, square it, and get 25. So f of 5 would equal 25. Find the domain of the function. This really is the domain. It's a list of x values that you're going to plug into the function, and this particular piecewise function tells us what to do with all of the x values, everything to the left of positive 2, including positive 2, and everything to the right of positive 2. So This function has been described for all x values. So answer using interval notation, and then sketch the graph of the function. I'm not going to look at all of those graph options, but I can tell you that if I look at x plus 2 and I think of it as y equals x plus 2, I know that that's a line with a slope of positive 1. I've got an m value of 1 in there. I've got a y-intercept of positive 2, so I come up 2 units. I'll put a point there at my y-intercept. I might go up 1 and over 1 and put another point, and I could snap a line through there. Thing is, I don't want that entire line because my function's only defined for as equaling x plus 2 if my x values are less than or equal to 2. So look back with me one more time at this graph. Let me go to the right one more unit and up my y-axis one more unit. I'll put another point there. That point has an x value of 2, and I'm not going to use anything to the right of there. So I've erased it right to that point that has an x value of 2. And I'm leaving it as a closed circle because my function is defined on this line where x equals 2. Notice in the piecewise function it says x is less than or equal to 2. Okay, and then what does the second part of our piecewise function say? It says x squared. Well, I know what the x squared graph looks like. Let me go back onto my graph here. It's a parabola. Maybe it looks like something like this. Well, actually, 2 squared is 4. 1, 2, 3, 4. This has a y-coordinate of 4. So my parabola really should have passed through the end of my line there. Let's draw it one more time. Parabola like this. Okay. And this parabola is only defined for x values that are greater than 2. So anything to the right of the point that has an x value of 2. So I'm going to get my eraser again and erase the left-hand side of this parabola as best I can. Oops, knocked out some of the x-axis there. Right to there. Alright, so that parabola would curve up and to the right out of the, as it turns out, right out of the end point of that line. So you'd have an open circle really at the base of that bit of the parabola curve that we just drew there. We get an open circle there because we have, or we're working with x being strictly greater than 2, except it turns out that the point 2, 4 filled in that hole at the sort of upper right-hand end of our line segment. It's not a true line segment. It's more of a ray because it has a starting point and goes down and to the left forever. But we don't want to get that technical. Alright, so I'm not even going to look at the graphs. I'll leave it to you to match that up, and you're going to run into some slightly different numbers. There's a plus, those 2's are going to change to some other values. What else have we got in this section? Question number 11, find an expression for the function whose graph is the given curve. Assume that the points are in the form x comma f of x, the line segment joining those points. If I can draw a diagram, and I'm telling you, I draw pretty lousy diagrams, which is why I have to label them as well as possible, because they're not super accurate. But I would try to sketch this thing. I've got to go over 3 units. That vertical axis doesn't really need to be there. Come on, pen. There we go. Over 1, 2, 3, 4, 5, 6, 7. Over 3, down 5. Over, that's not 3. 1, 2, 3, down 5. Over 7, up 1. Okay, so this is negative 5, and this is positive 1. See how bad that is? With a digital pen, it's even worse. With a pencil, My handwriting actually improves, although there's not much farther down I could go, I suppose. There's a line segment that joins these 2 points. Okay, super. And find an expression for the function whose graph is the given. Curve is a generic term. In this case, it's a straight line, but it's a segment because it's only part of a line. We're going to need a slope and we're going to need a y-intercept in order to find the slope of this line segment. Figure out how far did you rise and how far did you run. You'll have rise over run, m equals rise over run. So you're going to figure that out. That's going to give you an m value. And then please remember point slope form. Point slope form is, or is typically written, y minus y1 equals m times the quantity x minus x1. M you've just figured out. X1 and y1 will either be these x and y coordinates or these x and y coordinates. Pick one of them. Doesn't matter which one. This could be, the 3 could be x1 and the -5 could be y1, or the 7 could be x1 and the 1 could be y1. Pick one of those points to be x1, y1, plug them into this equation with your m value that you've determined, and then solve that equation for y. That is what will eventually go into this space. And then you need to figure out the domain of that function. Use interval notation. And I'm going to leave it to you to play with that. The function itself should have a domain of all real numbers. But in this case, because it's a line segment only going between those 2 points, the author here may want you to incorporate those x value restrictions. So see what you can do with that. And the last question in this section, number 12, says determine whether f is even, odd, or neither. I would encourage you to go and watch a video about determining whether functions are even, odd, or neither. There's a test that you can do, and it would be nice for you to see somebody march through those processes. It's been done so many times, I don't think I necessarily need to do it again, but I'll remind you of the test because this should be information that you know coming into this course. Your function is even if f of x equals f of negative x. For example, 3 squared equals -3 squared. So squaring is an even function. Your function is odd if f of negative x equals negative f of x. For example, -2 to the 3rd power equals negative +2 to the 3rd power. Right? Both of those is equal to -8. So cubing would be considered an odd function. And if both of those tests fail, then you're working with a function that is neither even nor odd. How are you supposed to figure that out and apply it to this function? You could try throwing in some numbers. If I were you, I would look and see if, try plugging in an a, capital A, see if f of a is equal to f of -a. If that works, then it's even. Otherwise, try comparing f of -a, which you've already determined here. See if that happens to be equal to the opposite of f of +a. You don't want to just plug in numbers. It's too specific. So just try this generic value of lowercase a. I hope that's a helpful review. See what happened there? I hope that's a helpful review of some algebraic concepts. We certainly could have done a review of even or odd functions using trig functions. You'll remember that cosine was an even function, as was its reciprocal function, secant. And the other 4 sort of basic trig functions were all odd functions. Other than that, I think we will move into section 2 next and see a little bit more review there. There's only a handful of questions, as I recall, and we'll keep working our way through the basics and these really good fundamentals toward doing some more serious stuff using calculus. But we're going to be using calculus and still talking about even functions, odd functions, increasing, decreasing. Where is a function neither increasing nor decreasing? That point's going to be a maximum, a high point, or a minimum, a low point. Most of which we just talked about in these 12 questions. So let's see how it goes, and I will see you in section 2. Thanks.